this factoring problem, you'll notice it's not set equal to 0. So we need to manipulate it so that it is. I'm going to go ahead and subtract cotangent squared x to the other side so that I have cotangent squared x sine x minus cotangent squared x equals 0. Now that I've got it set equal to 0, I can think about factoring. I've got a binomial, so that means I only have two options, GCF or difference of perfect squares. Do we have a GCF here? Well, if you notice, we have a similar factor in each of the two terms. So that's what I'm going to pull out. That's the GCF. So you've got cotangent squared x times sine x minus 1. Don't just leave this blank. When you divide something by itself, it does leave behind a 1. Now that we've factored it, we can set each of these equal to 0, and they'll have their own equations. And then we solve each one independently. This cotangent squared x, we're going to square root to get rid of the square. And we have cotangent x equals 0. And over here, we're going to add 1 and get sine x equals 1. Both of these, again, are quadrantal angles. I can tell because the ratio of 0 isn't going to exist between side lengths within a triangle, and neither is 1. So for each of these, I'm going to go ahead and this time, since cotangent is involved, I'm going to use the point method so that I can just kill two birds with one stone and not have to draw cotangent and sine. So I'm going to sketch out this whole little thing. And then I have to think about cotangent of theta in x, y, and r is x over y. Okay, I just remember what tangent is and flip it over. If you have a hard time remembering that, just sketch yourself a little triangle. The hypotenuse is always r. The horizontal side is always going to be x, and the vertical side is always going to be y. So then you can kind of just go, oh, adjacent, or adjacent over opposite. That's cotangent. So I'm going to look around and figure out where is x over y equal to 0. So 1 over 0, nope, that's undefined. 0 over 1, yes, that equals 0. So then I keep going, and I'm going to find out that that's the only one that works. No, it's not. There's two. I lied. Both of these two work. So that's why it's important to go all the way around, check them all out. So I'm going to say this angle is pi over 2, and this angle is 3 pi over 2. So two of my solutions then up here are going to be pi over 2, 3 pi over 2. Notice this doesn't ask for all possible solutions, it just asks for ones within the interval. So I don't have to put that plus 2 pi in on there. Okay, now for sine. Sine in terms of x, y, and r is y over r. So I look through and find where y over r equals 1. And in fact, it's going to be pi over 2. Well, that's a repeat of one of our earlier solutions. In algebra, whenever we had repeat solutions, we didn't list them more than once, so we don't have to do it here. And that's it.